All right, the wave equation. Let's understand the variables in the wave equation and use the equation to solve for unknowns. Here we go. So here's the wave equation. We've got that Greek letter lambda, and that means wavelength. In the numerator, we have v for velocity or wave speed, same thing. And F stands for frequency. Now, the wave equation means that wavelength is directly proportional to velocity, wave speed, and inversely proportional to frequency. Now, wave speed, let's go through these variables one by one and see if we can understand them better. So wave speed, just the same thing as the velocity of a wave. Don't overthink it. And velocity, of course, is the distance that you travel divided by the time that you travel that distance in. Distance divided by time. So my pro tip is you track the moving crest of the wave. So if we know we have an equation, velocity equals distance divided by time, we'll see how far that wave travels. It looks like it goes 6 centimeters, and it does that in 1.04 seconds. And we do our calculation, we find out that the wave speed is 5.8 centimeters per second. Easy peasy lemon squeezy. Wavelength. Now wavelength, it's just the length of one complete wave. Wavelength, length of a wave, no doy. Well, you can measure it by finding the distance from crest to crest, or from trough to trough, or from equilibrium point to equilibrium point. That's how you measure the wavelength of a wave. Now, the wavelength must capture one complete oscillation of the medium, one complete vibration of whatever substance the wave is traveling through. Now, I want you to recognize the shape of one complete vibration. So if you vibrate from crest to crest, you have a shape that looks like that. From trough to trough, looks like that. And from equilibrium point to equilibrium point, you see that S shape. And note that in each case, we're dropping below the equilibrium line and going back. You have to go from your original, the starting point of your vibration to where the maximum of your vibration point is, all the way back to your original starting point. It has to be a cycle, oscillation. Okay, so how many wavelengths are shown below? So look at that waveform. I see 1, I see 2, 2.5. There's 2.5 wavelengths shown in that waveform. Last one, frequency. Well, what is frequency? If a string vibrates 200 times in 1 second, we say that it has a frequency of 200 hertz. Those are the units, don't forget it. Frequency is how often a vibration occurs. So let's look at two frequencies. The speaker on the top image has a low frequency because look at how slowly the speaker's diaphragm is vibrating back and forth. The image below, that's a high frequency wave because look how quickly the speaker's diaphragm is moving back and forth. I'm looking here at the wave source, the thing that is creating the wave. So frequency of a wave is determined by the wave source. In other words, the vibration of the wave source is what sets the frequency, whether that's the moving diaphragm of a speaker or a jiggling electron creating an electromagnetic wave. So frequency, how do we find it? How do we calculate it? Well, we have a way to solve this problem. Frequency is the number of waves that pass through a fixed point in a given amount of time. So if frequency is the number of waves divided by the time, let's use this image here. I want to look at this little sun image here, and I want to count how many waves pass through that fixed point. And it looks like our time is 1 second. So 1 wave, 2 waves, 3 waves. We have 3 waves. To find our frequency, we have 3 waves in 1 second. And that's 3 hertz. And so that's how we can look at the waveform and we can solve for frequency. Last thing, you're going to get some wave equation problems where you put it all together. So 2 boats are anchored 4 meters apart. They bob up and down, returning to the same position every 2 seconds. When one is up, the other is down. There are never any wave crests between them. Calculate the speed of the wave. Well, they have this nice image for us. And we just got to write down what we know. Well, do we know the wavelength? Yeah, it's right there, 8 meters from crest to crest. Do we know the frequency? Well, it says they bob up and down, returning to the same position every 2 seconds. So that tells us that there's one wave every 2 seconds, or one oscillation every 2 seconds. So we know that the frequency is 0.5 hertz. And let's put it together in that equation. Wavelength equals velocity divided by frequency, wave speed divided by frequency. Can you substitute your known variables and solve for the unknown? I bet you can. Good luck.